Chapter 3, Lesson 1, Advanced Algebra, looking at graphing systems of equations. We'll be continuing our work with linear equations. We're going to take a look at what makes a system of equations, and then we'll look at how to classify those, as well as doing a little review video on writing linear equations and graphing those. So let's take a look at what a system of equations is. The paragraph here states that a system of equations is a set of two or more equations that use the same variables. So we're looking at two equations, both of which have the same variables in them, x and y, is what we'll be working with here. It says a set of two or more equations, which means that you can have more than two equations. In this chapter, we'll look at specifically two linear equations that make up a system, but there are those that have 3 and 4, which we'll look at later when we're doing some linear programming. If the graph of each system, if the graph of each equation in the system of two variables is a line, then that is called a linear system. So if we're looking at two linear equations, we're looking at a linear system. So a quick summary of that would then be that a system of equations is two or more equations. We use this little brace symbol on the left here to indicate that these are together. That's the only way we would know they were in a system. If we just had two linear equations listed, we wouldn't know they were in a system. So this is a mathematical notation identifying to us that these two go into one system. It also talked about if they are linear equations, then they would be a linear system. So that's what makes a system. Furthermore, it says a solution of a system of equations is the set of values for the variables that make all of the equations true. So what we're looking for as far as when we're trying to solve a system of linear equations is we're looking for the point or more points, all the points in fact, that make those equations true. You remember that each equation is a representation of the relationship between a particular x value and the particular y value, or the ordered pair. And if you substituted in the ordered pair into the equation and simplified it, both sides of the equation would end up being identical, or you would have a true statement. In a system, you're looking for one ordered pair, or more if there are, that when you substitute the x value and its corresponding y value into the equations, it's going to make every single equation in the system true. So algebraically, you're solving those using substitution or elimination, which we'll talk about in the next lesson. Graphically, what does that look like? What does it look like when you have a point that you could substitute into each equation and make that true? Well, what that means is that that particular point is on both of those lines. Well, how can a point be on both lines? Well, only if it's the point of intersection. So graphically, we're looking for the intersection point, and that's going to be the solution to the system. And again, it's going to make every linear equation in the system true. It's going to be an ordered pair, and it is the point of the intersection of the graphs. So when you're solving a system, you're looking for the intersection point if you're looking at a graph. In the first lesson here, we are going to solve these by graphing. It's probably the most inaccurate way to do that, because even though we may be very careful in graphing these on a piece of paper, we may not get the points exactly on the same, exactly where they go, and then when we draw the line, the thickness of the lead, or all kinds of variables can come into play and make that finding or determining that intersection point rather difficult or unsure at best. And so we need a way to check that or make sure it's true. Well, what did we just say? An ordered pair, or the solution is, if you took that ordered pair and substituted it into each equation, you'd get a true statement. So what you're going to do in this first lesson is graph these on a piece of paper, on that yellow sheet of paper that we've been using for our graphs. You're going to graph each line, so you use those graphing skills that you learned before, and then you're going to look for the intersection point, the ordered pair. You're then going to substitute that intersection point into each linear equation and see if you get a true statement. So here we have the equation x plus 2y is equal to -7. 2x minus 3y is equal to 0. We graph both of those. The intersection point appears to fall on a nice coordinate -3, 2. So we're going to confirm that by substituting it into each equation. So we substitute the -3 in for the x, the -2 in for the y. We simplify each equation, and it indeed does make each equation true, so that is our solution to the system. Now, a couple of notes about homework expectations, and then we'll wrap this video up. I'd like you to graph these on those graph pieces of paper that we've been using without a calculator and try to determine what the value is without the calculator. Now, that's going to work fine if it appears that the point falls on a nice coordinate where the lines intersect on the graph. So I want you to use it. However, if they don't exactly fall on the line, or you want to get a more accurate maybe picture and have your calculator do it, remember we talked about how to do that in class, where you graph each one on the calculator and then use the intersection calculation function to determine that value. When it says to check your answer, that means to substitute the values in to verify if it makes it true. So the application of this to word problems is if we're looking at two linear equations in the intersection, when you're looking at a word problem then, you are going to have to write two separate equations that again model what's going on in the word problem. So again, you're going to use those skills we talked about before, looking for phrases like varies directly, or function of, or remember time is always x, or cost is always y, looking for those two ordered pairs and writing those linear equations. Once you have the two linear equations, you'll want to graph those and find out where the intersection is. So that's what a system is. That's what the solution is. We'll wrap that up here, and in the next video I'll do a quick review of how to write linear equations, and then we'll take a look at the last topic in the lesson, which was I forget what the last topic was. What was the last topic? Looking at the equations and determining if there is a solution, or classifying the system. That's what I just remember. Classifying these systems of equations.